From the Spec Network, this is Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. I'm Don Felker.
And I'm Kaushik Gopal.
Welcome to the show.
Hey folks. I am really excited to share a very new sponsor for this week. So the sponsor for this week is Vettery. Vettery is an online hiring marketplace that is changing the way people hire and get hired. Now you might ask, well, I've heard of other similar companies like this. What's so different about them? Well, for starters, the access is exclusive. Once you're live on their marketplace, top employers can view your profile and extend interview requests via email. The other good thing about them is they're also specialized in the tech space. So the kind of jobs and positions that you'll see are the ones that you probably have the most context around. So software developers, data scientists, product managers, etc. You can also do things like set preferences for your desired location. And also if you are someone who's looking to find other engineers and other great people to work with, you can set all kinds of different tweaks like years of experience, top skills, professional background, and a whole bunch of other things. They also have about 20,000 companies that they partner with on this platform. So that's amazing. It ranges from innovative startups to, the Fortune 500 firms. So, and they're also across US, Canada, and the UK. Now here's the best thing. They are absolutely free to join. So you can go and sign up on vettery.com/fragmented. Vettery is kind of hard to pronounce in audio, but it's actually easy to type. So I'll just spell it out. It's VETTERY. So that's VETTERY.com/fragmented. And if you accept a job through Vettery, you get a $300 bonus on top of that. So again, if you can go to the link vettery.com/fragmented and try them out, then it helps support the show. And also they'll know you came from us and they'll know that you're interested in a service like this. Anyways, my thanks to Vettery for sponsoring this show.
This episode of Fragmented is brought to you by Flatiron School. Fall is in the air and kids aren't the only ones going back to school. At Flatiron School, the students are parents, musicians, travelers, and working professionals from all walks of life. It doesn't matter if you're an entrepreneur running your own business, a marketer diving deep into user behavior, or just someone who loves design. It's time to level up your creative chops. You can design your future by learning UI and UX design at Flatiron School in just 24 weeks at one of their global WeWork campuses or even online. Their committed instructors have both industry and teaching experience and are backed by their master's teaching and learning experience designers to ensure that you get the best possible support. Now, while in school, you'll work on client projects and graduate with a portfolio of real client work. This will enable you to change careers with confidence with one-on-one support from their dedicated career coaches and with a money-back guarantee. Complete details about Flatiron School, you can go to flatironschool.com/terms. Again, that's flatironschool.com/terms. And join the community of changemakers at Flatiron School at flatironschool.com/fragmented. Again, if you're interested, check out flatironschool.com/fragmented.
App modularization comes with plenty of benefits. Your build times are improved, compilation time is reduced, your CI most likely will start to run faster. Then there's a whole bunch of other things too. For example, if you leverage the new app bundle architecture, which modularization helps, you can reduce the delivery size of your apps, which can be a huge win. Dynamic feature loading, unloading, plenty of benefits to go around. I'm not going to explain app modularization in detail for this episode. There's a whole bunch of amazing resources already out there for modularization. I'll drop some of my favorites in the show notes. We actually even did an episode here, episode 117. Then friends of the show, Eat and Florina, in Google I.O. 2019, that is this year, they had a talk which happens to be one of my favorite talks in terms of app modularization. So definitely that. Our friends Joe, Birch, Jerome Moles, all of them have written great articles. I'll drop all of that. But if you're in the process of modularizing your app, inevitably there's this conundrum that you will run into. where do I put my database objects or entities? If you listen to previous episodes, you'll know that primarily there are two ways of modularizing your app. One way is to modularize by layer, and the other is to modularize by feature. It's very similar to the concept of packaging by layer or packaging by feature, which is something that we've also talked about in detail. I'm personally not a fan of modularizing by layer. I think in general you should always just put in the work to modularize by feature as much as possible. And in each stock from Google I/O, the one that I mentioned, the final recommendation that they go with eventually lands up being just that. They say, if you have a large monolithic app, the first step is to probably modularize by layer, because that happens to be the easier step. Then gradually you want to strive towards a world where you're able to completely abstract functionality and modularize by feature. And I honestly think that's like good advice. That's also the most practical way to go about it. But to help like understand this whole situation, or like the question that I posed better, let's take a precise example, as I think it'll make the problem more realistic and simpler to understand. Say I have a simple shopping application. I search the local database. I have like order items. I can place orders and I put them in a cart, and you can do whatever you want with the cart. So order items is a table that exists in the database that I can search on. Now, typically the way when you think about precise classes in your application, I would have maybe like an order item database object, which is basically the order item class as pulled directly from the database. So I have an order item class, and the representation of that directly from the database is a class called order item DBO. I add the suffix DBO to represent DB object, and this is like your database object. This has worked pretty well in the past because it also helps like differentiate that this is the direct database representation of that class, right? Now, I would never directly use this database representation in my view model or application. Now, in those layers, instead of like using the DB object directly, I would translate that into a direct class like an order item entity or like an order item presentation class. Now, personally, I like to just call these classes as the name. So say I have an order item DBO that I'm pulling directly from the database. I translate that into an order item. So order item is like really the name of the class that I'll be using. And again, as you can like probably tell from the pattern, the suffixes that I use DBO for database objects. Now, a slight aside, even if you have network requests, I like to translate these two. So I don't want to directly use my order item object inside the network request. People call these, I know like some people have thrown the name DTO, which is data transfer object. So you would call it order item DTO. There are like multiple names for this. I personally, for like network, the representation of the order item class as pulled from the network request, I usually like to call these order item wire object. So I add the suffix wire object just because I like the term wire, because it's like, over the wire. And if you haven't seen the show The Wire, it's a very good TV show. It's one of the all-time bests. So I use order item wire object as the suffix for the specific object. So just to recap, I have three kinds of classes. I have an order item DBO, which is a database object. I have an order item class, which happens to be like the presentation object. And really, this is the one that I pass around and use mostly in my application. So in my view model and in almost every place that I'm like dealing with business logic, typically I would use the order item class, which is also why I don't add a suffix, because that's the one I'm going to be using the most. And lastly, if you're curious, I also use order item wire object as the representation of the objects that come from the network calls. So now, given this like precise example, in a multi-module Android app, where do you think each of these objects should live? Specifically, if you have multiple modules, where would you put these objects? That's like basically the question I want to ask today. Now, there's obviously no right answer, and depending on the state of modularization for your app, your answers might actually differ. Rightly, they should differ. But I just thought it was an interesting problem to think about. Like, I just like to pose this problem and spend some time thinking about it, right? Like, if given a hypothetical world, where would you place these things? What would be the best solutions be for these? Now, the cleanest solution would be a world where you have modularized by feature. This will mean you have the order item DBO and the order item wire object be internal to that module. So to make this more specific, I would have a module called probably lib order items, which holds all information about my order items, and I would have a feature A depend on this lib order items module. Now this lib order items module would have my order item DBO, my order item wire object probably, and my order item just the order item class, the presentation one that I talk about. The difference would be that the order item DBO and wire object would be internal to the module. So they'll have the internal modifier, and the order item would be the one that would be public. So that when the feature A depends on this lib order items, the only one exposed would be order item, right? So in this way, we leverage the right kinds of encapsulation to deal with placing these things in the right module. Now, if another module again needs the order item functionality, then they just simply depend on the lib order items module as an implementation, and all is well. This sounds great in theory, but when you actually try to build an application and try to do this, you'll run into some things that make life a little difficult. So things start to become a little tedious. The first problem that comes to mind is with this setup, every library or feature module will basically have to have its own database if you think about it, right? So if you use Room or SQLite, two of my favorite database libraries, if you use this, things start to become really hairy because each module will have to have an independent database file. And the funny thing is, this is actually a solution that is recommended in a pure multi-module world, right? But it just makes things a little complicated in my mind. So say order items today will need a database in this module. Tomorrow, if I create, say, a new module, this is another problem. Say lib order items is one module. Tomorrow I create a new module called lib money, right? Because money has cash items and cash order, cash objects, and just an example. So in this world, your money module will have to again have its own database, right? And that starts to become hairy. Also, your database library might not necessarily support that. Room, I think, supported that for quite some time. SQLite recently has started supporting. So before that, you didn't even have the option, right? And if you're using some other database library that doesn't allow you to necessarily create these multiple databases and allow them to talk to each other in some way, things start to become complicated. The second problem that comes to mind for me is and I think this is more of a real problem for me, it actually affects the way relationships can be formed between these entities. Say I have an order item which has money or cash embedded in that as a relationship, right? Or I have the join between order items and money, the money class. I don't know, it just sounds like this is going to be really complicated because I have to reach across multiple modules. Then I'll probably have to create another intermediate module that joins the two and then have my feature rely on this instead of those directly. You can start to sense that this becomes a little more complicated than usual, right? And lastly, the third problem is what I alluded to. I just feel in terms of maintenance, this is going to be a little complicated, right? It also just seems non-natural to use a database like that. I mean, heck, in an Android app, we don't really have that many database items. Our database is tiny compared to our freaking backends, right? Our backend servers don't have that many databases, right? Per module, they don't have that many. We don't have 10 databases in our backend. So it just seems a little unnatural to me that we would have to go through so much trouble to get databases to work in a clean way in the multi-module Android app world. But all that being said, this solution is theoretically possible, and I think theoretically it is also the cleanest solution, because another one of my mottos that I really like in programming is I like to optimize my code for deletion. So I write code with the idea that I want to make it as easy as possible to like delete it. And I'll in another episode, I'll probably talk about this in detail, because I think it's one of those paradigms that's really helped me and helped the quality of my code. So thinking about this, like things like that, if you modularize the whole thing, if say like in the world where I have a lib order items module, it's clean, because say I want to remove order items for some reason, I want to remove a feature, I just boom, delete that whole module, and things just are clean and like they're removed from the system. The other thing I'd like to point out is that some folks have actually reported success using this clear solution. So this is really in the realm of possibility. I'm not talking about this as something that like is really hard to do. I just personally have some aversion towards it, because it seems like it's a lot of boilerplate and a lot of ceremony involved in joining these things. But for example, Karan Trehan wrote a really good blog post, and I think this is like a very good blog post on how to write a modular project on Android. He's also the one that I think pointed, like I think through a GitHub issue, I like saw his blog post where he asks this question to Eat, and Eat actually gives the same answer, that hey, create multiple like databases and like embed them in your module, in your respective modules. I'll drop a link to that blog post as well in the show notes, so you can take a look. Now that's the cleanest solution. The other solution you can go with, which is somewhat of a compromise, but I think actually practically it works pretty well, is you have a single module for your entire database, right? So modularized by layer all the way there. A colleague of mine, by the way, as an aside, wanted to gently troll our iOS colleague. So he actually named this module the core data module, right? So instead of the core database or core DB module, he just called it the core data module. If you've done some iOS development, you'll know why this is kind of funny. Anyway, so this core data module basically houses your entire database. You have just one single database that is in this core data module, right? So as you can imagine, it'll house also, this module will also house all your DBO objects. So any DBO suffixed object, like the order item DBO that I mentioned, all of them here, right? The advantage with this again is if you use Room or SQLite or one of those other dependencies, this is the only module that needs to know about those dependencies, right? So I don't have to like embed, which is another problem with the previous solution. Like you don't have to have this dependency splashed across all your different modules. And tomorrow, if you decide to like swap out one database for another, because I've had to like do that too. I've started with Realm, I've moved to Room, and in different projects, I've like moved like in the opposite direction. Like it becomes very tedious if you have your dependencies just like splashed all throughout. So this is like one nice and again clean way to do it, where you just have a single module that houses your entire database and all the database objects. But you obviously want some layer of like separation again. So what you do is you create an intermediate module. So let's like give specific names, because as this is audio, it can become a little hard to comprehend what I'm saying. Let's call this lib. So I have a core data module. This is the database module. Now I'm going to introduce a lib order item data module, right? So this is a library that I'm calling order item data module. This is different from the order item module. So there are three modules. There's the order item module, there's the order item data module, and then there's like my core data module. This order item data intermediate module, I'm going to keep calling this the intermediate module because it makes it easier to reference to it, basically depends on the core data module. But the primary responsibility in this order item data module is to translate that DBO object into the presentation of the order item object. So if you think about where you would place, which is to answer the primary question, where would I place these classes or these objects in my different modules? Order item DBO, which is the database object, lives in the core data module. I have my order item data module, which has order item. That's like the presentation entity that's used across, and that'll probably be used in many places. But primarily in this module, what I'm doing is I'm translating the order item DBO into the order item, which then means the order item data module depends on core data module. So far, so good. And what you would do is in your actual feature, say I have like a feature A, I call this order item, but like forget about what I said. Say I have a feature A that needs to use order items. That would depend on the order item data module, right? So if you can see how what we have done here is like, again, we've abstracted away the database so that the feature has no knowledge about the database. It only directly depends on the order item data module which has the order item presentation entity thing that we're using, and that's used in the features, right? And that'll be used in most places. So everywhere, in most places in the app where I need to use an order item, I would depend directly just on the order item data module. And in this way, I'm again like removed from, there's a clean layer of separation between the database module and this module. This has the advantage of like, again, reducing the complexity in the way you wire your database, but adds like sort of this additional complexity in the dependency graph between your modules, right? Because you're creating this additional module. Now you have like a core data module, you have like an order item data module, and you have your feature module, which depends on this, right? So it's, again, in the end, it's all about trade-offs. I actually like this approach more than the cleanest solution. Admittedly, it is like some kind of compromise, but the reason I like this is because I feel more comfortable handling the complexity in the dependencies between these modules than I am with the complexity in the databases, right? Like if I have to think about like Room or SQLite and having these multiple databases and then having these migrations and like making sure everything is, I would just rather keep that a plain vanilla solution. I want to keep my database as closely to the vanilla example that you would find on the README as possible. So at least that's my approach philosophically. So that sort of should help answer the question. But before I wind this episode down, I also want to do like a reality check with you folks. Sometimes even this compromise solution that I proposed can tend to get tedious, right? And I'd be lying to you if I said I'm like very diligent about always creating these order item data modules or like these intermediate data modules for every single feature. In the end, you know what? I just want to ship features. And I can't like necessarily create this myriad of dependencies to basically just build a basic feature. In the end, you know, hey, like it or not, 40% of our time in building an application is built in just building simple features, right? I have this thing. I want to make a network request. I want to do a database request. I just want to show it to my user. Life shouldn't be necessarily that complex where I have to like wire these crazy sort of modular dependencies and make sure that I have the necessary abstractions. It tends to get like very complicated when all I want is just a simple feature. Like, you know, in the early days when we had just monolithic Android apps, things were easy. It was like easy to build up, like it was easy to get up and running and build a feature. You know, if a PM came to me and said, hey, I need this feature, I can just tell them like, you know what, fine, like in a week or two, I will get this thing done with confidence. And now, obviously, again, there are like different ways to argue this point, because like if you already have this approach well laid out, then it's just copying boilerplate. So you might argue against my point that way. But for the most part, I feel like I would like to keep things simple. So if you ask me, if you pull me aside and tap me on the shoulder and say, hey, when no one's looking, what do you really do in this world? I'll be honest and tell you, I actually don't create that many modules. I do have a core data module. In that core data module, I actually place my order item DBO. I also place my order item object, and I place my order item wire object, right? And the features would depend directly on this module. I know there's like a lot of red flags and alarms there. Why do you have like the database dependency directly? You know, that is life. That is how I've chosen to like make things easy for me. I comfort myself at night by basically saying that I do have those abstractions though. So even though my modules are not like abstracted that much, my actual classes are and my packages are abstracted that way. I still have an order item object. I still have the order item DBO object. I still have my order item wire object, and I do the necessary translations to get them into the right class fashion. But my thinking is, you know what, if I want to build a feature quickly, I don't even know if this like feature is going to last, right? Like in 2 months, like we might realize that this thing, like this feature doesn't really work, or it doesn't reach significance, and I might have to scratch the whole thing. I'm not going to like wire these crazy complex dependencies and do all this work if it's going to be if it's going to be thrown away. So I do keep the classes, I do keep those abstractions ready so that it becomes easy for me in the future if I've said, okay, you know, this thing's stable and things are starting to get really messy, where I have a lot of different like responsibilities in this core data module. I want to start teasing these apart. Then I can rest assured that in the future, I can maybe then modularize that and then, you know, maybe go the route of creating my order item data intermediate module. And then, you know, one fine grand day, I can even go further and then modularize purely by feature. But that's the approach that I usually go with. I do want to mention that, because in the end, I don't want people to necessarily get tired and think about oh my God, this is the recommended way that people have said, so this is probably what everyone is doing. I'm the only one here secretly, shamefully building my app in this non-recommended way. No, you are not alone. Trust me. In the end, everything is a trade-off. As engineers working in the business, part of our responsibility is to know when to make these trade-offs and when to stand our ground on these principles and pure principles. So anyway, I hope you found this episode useful. Feel free to hit me up on Twitter if you think I'm crazy, or if you've shared similar thoughts, or if you've had different experiences. Maybe something that I've said isn't necessarily as difficult as you've felt practically when you've used it. I'm genuinely interested to see how the community approaches this problem, and what I think is actually a pretty common problem these days, especially with a lot of this app modularization paradigm being carried out and pushed by Android developers. Anyway, thank you all for listening, and I will catch you in the next episode.
Flatiron School is a sponsor of Fragmented. At Flatiron School, you learn how the future is being built so that you can change anything, starting with a new career in UX and UI design. To learn more, you can go to flatironschool.com/fragmented. Again, that's flatironschool.com/fragmented.
I also want to take a moment and thank our sponsor for this show, Vettery. Vettery is an online hiring marketplace that is changing the way people hire and get hired. You can go to vettery.com/fragmented, and if you accept a job through them, you'll get an additional $300 bonus. So it's an additional offer. It's hard to say that on audio, the domain name, so I'm going to make sure I spell it out. It's vettery.com. So it's vettery.com/fragmented. Do make sure you put the /fragmented in so that they know you came from us. Thank you so much, Vettery, for sponsoring today's show. That's it for the show, folks. Fragmented is hosted by Don Felker and me, Kaushik Gopal. We edit and produce all the episodes here on Fragmented. Sarah the Amazing Jackson from the Spec Network helps with production assistance and wraps our final mix. Our theme and ad music is by the national recording artist Blueprint from Weightless Recordings. You can find more Fragmented episodes at fragmentedpodcast.com. Thanks for listening, and we will catch you in the next episode.